The next number I want to talk about is incubation time. So again, hypothetically, somebody sneezes right in your face who is positive for coronavirus. How long do you have to wait before you show symptoms, supposing that you contracted it? Again, I'm just using data from Worldometer just because we can. It's a good enough site, and it has a nice organization of data. Again, the CDC is still a great place to go. The World Health Organization, a great place to go. Lots of good information there. It's just not always displayed very helpfully. So here's the coronavirus incubation period. They have a whole web page, Worldometer, on the incubation period, and this is what you see when you land there. And this was on March 25th. It had not been updated since the 12th. 2 to 14 days, with possible outliers 0 to 27. So what does that even mean? So what they're suggesting here is that most people present between 2 and 14 days after exposure. Some people present same day, and some people don't present until 27 days later. Now the 27 days is the really scary thing. It's the idea that there are people walking around for more than 3 weeks who could be spreading the disease. So I want to deal with that fear. The CDC currently reports that you're not likely infectious if you're not presenting. So if you don't have a fever, you're not sneezing and coughing and stuff, you're probably not spreading it. This is all early research. You know, the world is working furiously to study this virus, to produce new research, to answer questions. And the more we go on, the more certain we'll be in claims and evidence for those claims. But 2 to 14 days is what most people experience, and we'll quantify most in a moment. This 2 to 14, this is important. You know, a lot of the discussion has been about, you know, shutting things down for a couple of weeks. Why a couple of weeks? Well, because if people could shelter in place, minimize contact, not interact, not go out, and stay somewhat isolated for 14 days, then everybody who has COVID-19 would then be symptomatic. We would know who they are, we could test them, and we could quarantine them, and they would no longer be interacting with other people. All right. If we didn't wait, then as those people start to develop symptoms, as they sneeze here, cough there, wipe the nose on their hand, open a door, then that furthers the infection while we're not. And you know, if you think about your college campus, how many people did you interact with? Sitting in classrooms, opening doors, going through elevators, going to the union. The idea is to reduce that dramatically and wait for everybody to present. Now, this works best when everyone's on board, and certainly not everyone's on board, but this is where the 2-week time period is coming from. Now, there are these possible outliers. So there's been a bunch of studies, and there's a bunch of numbers out there. Remember, mean is average. So averages of 3 days, 5.2 days, 6.4 days, median of 3 days. Remember the median, right? So for the study that quotes a median of 3 days, that means half of all cases present within 3 days. That's reassuring. That means if you go to the grocery store and you do your best, you wash your hands and everything, you should know within 3 days, half of people should know within 3 days whether they contracted it just by being out and about. All right. But then there are these outliers, and outliers always exist. In any probability distribution, you have outliers, which is why we do read articles about young people who are athletic and great health, who are suffering severe respiratory failure and dying. They're not as common, but they're almost certain to happen. Rare things happen, right? Unlikely things happen if you see that thing occur often enough. With enough people infected with the coronavirus, we will see extremely unlikely events. There has been an infant that has passed away due to COVID-19. It's an unlikely event, but it is going to happen, and it'll happen again. as time goes on. So on the same webpage, the Worldometer webpage on incubation, you'll see a statement like this. And we saw statements like this when we looked into polls, the presidential approval by Gallup, Rasmussen, and Pew. There's this confidence interval. So the mean incubation period was 5.2 days, 95% confidence interval, CI, 4.1 to 7, with a 95th percentile of the distribution at 12.5 days. This is the kind of statement that I wish everyone would be able to read. And you don't need all the fancy computations that most of us have been dragged through in our I can never say that word, stats class. So what does this mean? Well, 95% confidence interval, what that means is if we tried this 100 times, you took groups of people 100 times, 95% of the time, you would see the incubation period between 4.1, you see the mean, the average, between 4.1 and 7. So if you take a group of people and you calculate it, the average, the odds of it falling between 4.1 and 7 are 95%. So that's good, between 4 and 7 days. In the course of a week, you should know. Now, what does this second part of the sentence mean? With the 95th percentile of the distribution at 12.5 days. Again, percentiles are the kinds of things you saw on your standardized tests when you were taking them in high school. You know, maybe your reading was at a 95th percentile, meaning that you performed better than 95% of the other participants. So what this means is that 95% of people present symptoms in less than or equal to 12.5 days. So only 5% of people present after or equal to 12.5% days. Sorry, 5.5. So most people, 95% of people, are presenting in less than 2 weeks. So think back to all this stuff in the news about hunkering down for 2 weeks, closing things down for 2 weeks, orders to suspend XYZ for 2 weeks. The idea is that 95% of the people who have coronavirus will have expressed symptoms by then. So we know who they are, we can quarantine them, we can keep them from interacting with healthy people. That's how we can stop the spread. Yeah. Again, these are all still estimates. What is the actual incubation period? Don't know. You know, we'll know more after everything's over and all the data can be analyzed. But we can't wait for that. Also, because if we wait for that, more people will die, more people will get sick, more money will be lost. So we're in this this part where we're trying to estimate things that we will know better later, but we need to know them now. All right, that explains that. And so this slide is just kind of summarizing all the things that I was saying. Here's a quote from the webpage. Understanding the incubation period is very important for health authorities as it allows them to introduce more effective quarantine systems for people suspected of carrying the virus as a way of controlling and hopefully preventing the spread of the virus. If you think somebody has been exposed, how long do they shelter in place? 2 weeks is a pretty good range. You should see within 2 weeks. So that's what that number means. All right, this is more stuff if you review the slide that you'll see. All right, so as I said earlier, the CDC reports that during this incubation period, the person is likely not infectious. If they're not running a fever and they're not sneezing and coughing on people, then they're probably not. This fact is important for modeling the condition. Next week, I'm working on slides for next week already. We're likely going to look at some different mathematical models for disease spreading. There are a whole bunch of them. And based on the properties of this coronavirus, we're probably going to use the SEIR model. So S stands for susceptible, that is people who can get the condition, which apparently is anybody. E, person's been exposed, but is not yet infectious. They're not presenting symptoms and they're not spreading it. Infected, meaning that they're infected and they're presenting conditions and they can affect others. And then R is recovered. Now this model doesn't have deaths in it. A lot of the mathematical models don't have deaths in it, which might seem very weird. We'll address this next week. These models can still tell us a lot about how diseases spread and how the spread is affected by the actions of people, by societies, by groups of people. All right. So knowing how long you're in each of these categories is important. How long before you go from exposed to presenting symptoms? How long are you sick before you're recovered? And then also, if you're recovered, do you then have immunity? And preliminary research suggests that when you recover, you do have immunity, although it may not be forever. It may not be like chickenpox, for example, is that once you're immune forever. Other coronaviruses have immunity that wears off eventually, though even if you lose immunity, if you contract it again, it's a less severe case. So there are models for that too that we'll look at next week. Practice time.